wandering the chemicals used in producing the white foam. The journey from raw chemicals to everyday comfort begins here, in a highly controlled industrial environment. Primary chemicals used in the process you see in the video. 1. Polyols, the base. 2. Diisocyanates, the reactant. 3. Blowing agents, the rising secret. 4. Catalysts, the accelerators. 5. Surfactants, the bubble stabilizers. Imagine, polyols equals the flour. In the virtual world of baking, polyols are the flour. The match, just as flour provides the bulk and substance of a cake, polyols provide the main body of the foam. Without flour, you have no cake. Without polyols, there is no foam. 2. Diisocyanates equals the eggs, the bridges. Think of diisocyanates as the eggs in your batter. The match, in cooking, eggs bind the ingredients together. In foam chemistry, the isocyanate creates crosslinks, or bridges between the polyol chains. This turns a liquid puddle into a solid, connected structure. 3. Blowing agents equals the yeast/baking powder. These are the rising secret. The match, when you add yeast to dough, it releases CO_2 gas that creates holes and makes the bread rise. The blowing agents, like water reacting with chemicals, do the exact same thing. They pump air into the plastic to make it fluffy. 4. Catalyst equals the fast-forward button. Think of catalysts as the turbo mode on a video game controller. The match, they don't actually become part of the foam, but they make the reaction happen at lightning speed. Without them, the chemicals would just sit there for hours. With them, the foam rises in seconds, perfectly timed for the moving conveyor belt. 5. Surfactants equals the soap, suds/bubble wrap. These are the bubble stabilizers. The match, have you ever noticed how dish soap makes bubbles stay strong and not pop immediately? Surfactants act like that soap. They lower the surface tension so the millions of tiny CO_2 bubbles don't collapse before the foam hardens. The process begins not with fabric, but with chemistry. Large-scale tanks pump a precise blend of polyols and diisocyanates into a high-pressure mixing head. Think of this as our industrial flour and eggs. To get that signature cake rise, blowing agents are introduced, creating a surge of carbon dioxide that transforms liquid into a massive, expanding loaf of foam. The rising slab, bubble stabilization. As the mixture is poured onto the moving line, it undergoes a rapid expansion. This is where surfactants, our bubble stabilizers, work their magic, ensuring the cell structure remains uniform and doesn't collapse. Meanwhile, catalysts act as a fast-forward button, hardening the slab just in time for it to reach the cutting station. The precision slicers, shaping the cake. Once the foam has cured, it moves through a series of automated horizontal saws. Much like a bakery slicing a giant sponge cake, these blades move with sub-millimeter precision to create layers of varying density. This allows the factory to stack different types of foam, some for support, others for that cloud-like softness. The spring core, internal architecture. But foam is only half the story. The skeleton of the mattress consists of hundreds of individual pocket springs. Each coil is wrapped in its own fabric sleeve, allowing them to move independently. This structural engineering is what prevents motion transfer, ensuring one person's movement doesn't wake the other. 620. The final assembly, stitching and closing. In the final stages, the foam layers and spring cores are cladded together. Watch the incredible skill of the technicians as they use heavy-duty industrial sewing machines to tape the edges. This final seam binds the aesthetic fabric to the internal layers, creating a durable, finished product that is ready to ship. The lamination process, the glue of comfort. As the internal layers are stacked, a specialized adhesive is applied. In this industrial setting, precision is everything. Too much glue, and the mattress loses its breathability. Too little, and the layers shift over time. This bonding process ensures that the flour of our foam and the skeleton of our springs act as a single, unified unit. The edge support, the framework. Notice the thicker, high-density foam being placed around the perimeter. This is the edge support. Without this rigid frame, the mattress would sag when you sit on the side. It's a structural detail that separates a premium build from a standard one, acting like the crust that holds the soft center of our cake together. The quilting station, the final aesthetic. Now, the top, ticking, or fabric cover is quilted. Multi-needle industrial machines dance across the surface, stitching intricate patterns that aren't just for looks. They actually help manage the tension of the fabric, allowing it to stretch and breathe as the foam beneath it reacts to your body weight. The compression and roll, the logistics miracle. In one of the most satisfying parts of the process, the finished mattress enters a massive hydraulic press. It is flattened with several tons of force and vacuum sealed. By removing the air from our foam bubbles, the factory can roll the mattress into a box a fraction of its original size, drastically reducing the carbon footprint of shipping. The quality seal. Before it leaves the facility, each unit undergoes a final inspection. From a liquid chemical reaction to a finished sanctuary of sleep, we've seen how industrial chemistry and human craftsmanship collide. This is the final stage of the mattress cake journey. The fatigue test, simulating a decade of sleep. But the process doesn't end at the exit door. In a dedicated testing lab, sample mattresses from each batch face the roller test. A massive 140-kilogram drum rolls across the surface thousands of times. This mimics 10 to 15 years of human movement in just a few hours, ensuring our chemical cake doesn't lose its balance or develop a permanent sinkhole in the center. 12:15. The airflow analysis, the breathability science. One of the most technical steps is the porosity check. Since we use surfactants to stabilize the bubbles, we now measure how much air can pass through them. High-quality foam must breathe to dissipate body heat. If the cells are too closed, the mattress becomes a heat trap. If they are perfectly open, the foam remains cool, dry, and comfortable throughout the night. The textile library, choosing the skin. Beside the heavy machinery lies the textile station. Here, high-performance fabrics, often infused with cooling gels or antimicrobial silver threads, are selected. This skin is the final layer of the documentary story, acting as the interface between the industrial chemistry inside and the human skin outside. The circular economy, the scrap recovery. Efficiency is the silent partner of the Korean mattress industry. Look at the trimmings being collected by the vacuum systems. These offcuts of foam and fabric aren't waste. They are baled, shredded, and recycled into high-density carpet underlay. It's a closed-loop system where every gram of our original polyol and isocyanate mix is put to productive use. The human-machine harmony. While the machines handle the heavy lifting, notice the hand finishing on the corners. These artisans check every stitch and every tape edge seam. It is this hybrid of robotic precision and human intuition that ensures that the soft cake mattress doesn't just look good, but provides the structural support needed for a healthy spine. The curing warehouse, the resting period. Just like a loaf of bread needs to cool before it's sliced, these finished mattresses enter a temperature-controlled curing zone. Even after the outer fabric is stitched, the internal chemical bonds of the polyurethane are still stabilizing. This resting period ensures that the foam achieves its final memory, the ability to contour to a sleeper's body and bounce back perfectly every morning. The vacuum seal, the magic shrink. Watch as the heavy-duty hydraulic press engages once again. This is the roll-pack technology that revolutionized modern furniture logistics. By applying over 50 tons of pressure, the air we carefully trapped inside those surfactant-stabilized bubbles is squeezed out. This turns a massive 12-inch thick mattress into a flat, 1-inch sheet of material without damaging the cell walls. The automated roll, the coil and wrap. Once flattened, the mattress is fed into a high-speed rolling machine. Wrapped in industrial-grade recycled plastic, it becomes a compact cylinder. This isn't just about convenience, it's about efficiency. One delivery truck can now carry 5 times the inventory it could 10 years ago, drastically lowering the carbon footprint of every garage art delivery. The expansion, the memory activation. The true test of our chemical engineering happens in the customer's home. When the vacuum seal is broken, air rushes back into the cells we stabilized with surfactants. The mattress inhales, expanding to its full height in seconds. This is the polyurethane memory in action, the polymer chains returning to the exact structure they formed back in the curing tunnel. The zone support geometry. If we look at the cross-section of the cake, we see zone support. By using different catalyst ratios, the factory creates firmer foam for the lumbar region and softer foam for the shoulders. This geometric layering is calculated by AI to ensure that no matter your sleeping position, your spine remains perfectly aligned. The microclimate, heat dissipation. But comfort isn't just about softness, it's about temperature. The open cell structure we saw under the microscope acts as a natural ventilation system. Every time a person moves, they act as a bellows, pushing warm air out of the foam and drawing fresh, cool air in. This passive cooling is the final gift of the blowing agents used in Phase 1. The legacy of the batch: each mattress is a snapshot of a single day's production. The humidity in the factory, the temperature of the mixing head, and the tension of the sewing needles all leave a unique fingerprint on the finished product. It is a massive industrial achievement hidden beneath a simple white fabric cover. The conclusion: the industrial art. From a volatile chemical reaction to a silent sanctuary of rest, we've witnessed the birth of a soft cake. It is a journey of precision, scale, and human intuition. Next time you lay down to rest, remember the machines, the chemistry, and the artisans that made it possible. This is the energy of the modern garage, scaled for the world. Now that you've seen the secret chemistry behind the mattress cake, you'll never look at your bed the same way again. Which part surprised you more? The liquid chemical pour or the vacuum-sealed shrink? Drop a comment below. And if you want more satisfying industrial documentaries, subscribe and turn on notifications. You won't want to miss what we're cooking up next.